Hi everyone. I'm not sure. We're having some technical issues. Is Boris, are you there?
Yes, I am.
There you go. I think we're missing Jason. Not sure what
Yeah.
happened to Jason.
I saw him a few seconds ago.
I know, so did I. While we wait for him, I will welcome everyone. I might even show my face. I'm so sorry that I'm not in uniform, but yeah, thanks, Boris. I'm not sure Jason will surely appear. Not sure what happened, but thanks everyone for joining us today. We've got Boris from FWPA, and thank you, Boris, for joining us today. Boris, do you want to talk a little bit about what we're going to be discussing, and we'll go on from there.
Yeah. Look, I'm more than happy to start, Vander, if you like, and then when Jason joins us, but I can talk a little bit about myself and about the presentation today. So, what I might do, I'll just quickly share my screen, because I've got a little bit of a presentation to go through that'll make it a bit easier for me to just talk about the cladding standard. So hopefully you can see that there, Vander.
It's almost, it'll start saying it's, yeah, perfect. Yeah, I can see it now.
All right. Okay, look, I might as well make a start and Jason can join us later. Okay, thanks, Dan. Good afternoon, everybody. My name is Boris Iskra. I'm the National Codes and Standards Manager at Forest and Wood Products Australia. Today, I'd like to just talk to you about a recently released industry standard developed through FWPA for the design and installation of exterior timber wall cladding. Just a little bit of background as to FWPA, or Forest and Wood Products Australia. FWPA is an industry services company. We provide a whole range of, or undertake a whole range of activities in support of both forest and wood products in the marketplace. And we do a range of activities from statistics and economics. We help fund research and development, codes and standards, which I'll refer to. And we've got a wood solutions program that you may have heard of, with a very substantial website that contains a lot of information about timber and forest and wood products. The program area that I look after is the Codes and Standards program, which is where the development of the timber cladding standard was undertaken. If you're interested in the work that FWPA does in terms of codes and standards, you go to the fwpa.com.au website and look up standards. And you can also subscribe to updates and get information about the work that we're undertaking. Some of the recent work that we've done is the release of a number of visual grading standards for recycled timber to cover both structural uses and appearance grade. The key one today that we'll talk about is the exterior timber wall cladding standard. We're also developing up standards in relation to test methods for timber connectors in that structural area. But as I've said, and as we know, today we want to talk to you about the timber cladding, or the use of timber cladding in particular. So why was the standard developed? It's really to try and build confidence in the use of timber products, and also to help simplify compliance. The standard itself takes a risk-based approach, and I'll run you through briefly what that means, so that we can identify the potential hazards in relation to weatherproofing and water penetration into through our cladding systems, if that occurs, but also trying to extend the use of timber cladding beyond our domestic houses. You may or may not be aware that for the use of timber cladding, it's been available for use on domestic housing under Volume 2 of the National Construction Code. With this standard, we've extended that for use in commercial type buildings, or low-rise commercial buildings, and also providing best practice. G'day, Jason. We've started the webinar.
No, keep going, Boris. Sorry about that, everyone.
Okay. Yeah, okay, no worries at all. So as I was saying, just to provide a bit of best practice for the installation of timber cladding. The standard covers a range of things, so it looks at the materials and enables you to select systems, It addresses both moisture, so moisture ingress and condensation management, provides ability to design, fixing design, so covering different wind speeds around Australia, and also, as I mentioned, the risk-based approach, provides installation and detailing, discusses durability, and overall looks at the resilience and enable you to design for a site-specific building.
Boris, as well,
Yes.
picking up with some of the questions.
Yes.
There's a question from Niall Scott. So this is referring to Type C construction only then for external facades, presumably, is the question?
Look, when you say Type C, we've got Type C construction, so it will basically cover off Type C in the commercial space as well. So in effect, wherever you can use that Type C construction on buildings, you can utilise the cladding standard. So no, that's correct. Yeah.
Thank you.
By all means, Jason, if there are any questions, just jump in.
I'll come in as they come through, mate. Yes.
Yeah. No, that's great. Thanks. And look, it's meant to be informal, isn't it, Jason? I'm sort of going, I've got through a bit of a presentation, so I can keep on.
Absolutely. Yeah. Any questions,
online,
please put it in the chat room. And Ralph, just to answer your question while we're here too, it's an informal CPD, so we'll send out the certificate at the end of this session for you. There's no questionnaire that's required.
Yeah.
Okay, keep going, Boris. Thank you.
So look, just talking about the National Construction Code, and we're probably aware that there's a new code, a 2025 edition, that's about to be called up in a range of states around Australia. But what I thought I'd do now is to just talk about where we've come from, or where we are currently, under NCC 2022, and then where we're meant to be heading under 2025. But just as the overarching comment, the main requirements that you need to comply with are the performance requirements of the National Construction Code, or the Building Code of Australia, as we often refer to it. But the National Construction Code, the legal requirements are the performance requirements. And the way to meet those performance requirements, there are two pathways. On the left-hand side, the red dashed rectangle showing the performance solution, and on the right-hand side is the deemed to satisfy solution. So there are two basic pathways for compliance purposes. So what I want to do is to sort of briefly talk about both of those as I go through the next few slides. First, I'll focus on the deemed to satisfy, which is where we've got potential changes that are occurring. So currently under the NCC 2022, where you're installing a pliable building membrane, you need to comply with relevant standards for the membrane itself, as well as the installation of that membrane. And then the NCC stipulates the type of membrane in terms of its permeability or permeance that it needs to achieve. So it nominates climate zones 4 and 5 with particular permeance, and then also for climate zone 6. So if we look at that, and there was a commentary or an explanatory information under that particular clause that nominated the type of membrane that was required based on class of membrane, which is the way that they get referred to or defined. So it defines the membranes that can be used. And for climate zone 6, you could use a class 4 membrane, which is still today's. But you could then, in effect, do what you want to do with your cladding, as long as you use those membranes between the cladding and the structure, so sandwiched in between your cladding. What the NCC 2025's done is actually made a modification to that, where it's now it's going to stipulate that for climate zone 6, 7, and 8, there are areas where it's got a no cavity with a cross. Basically means you must have a cavity. So the no cavity solution is not there for those climate zones under the deemed to satisfy, and so therefore you're requiring a drained and ventilated cavity, and still with that membrane, the class 4 membrane in the climate zone 6, 7, and 8. Obviously, the other climate zones have different permeance requirements, depending on if you've got a cavity or not. So that's under the deemed to satisfy pathway. One of the reasons for developing up the industry standard was to enable us to do this from a risk-based pathway. So at the moment, the standard is an industry standard, but it can be used under the performance solution pathway under both the NCC 2022 and the NCC 2025. So in effect, there's a procedure that you follow when you're doing a performance solutions, basically engaging with your building surveyor and other stakeholders. If you're doing a house, it's going to be your client as part of those discussions, and just getting endorsement by the building surveyor certifier that you're able to utilise the standard. So it's just via agreement. And I'll go through how the standards develop to give you the confidence that you can do that. It does utilise...
Boris, sorry.
Sorry, yes.
Yeah, to clarify, just one question. Sorry, an email.
Yeah.
Can you remind everyone what parts of Australia are Zone 6, 7 and 8?
Look, basically climate, because I'm based in Victoria, my mind tends to focus here. So basically the main capital cities are down south. You get a climate zone 6, such as Melbourne. Climate zone 7 gets out to the regional areas, and climate zone 8 is the alpine or mountainous areas. The climate zones obviously change as you go up north. So you move into the warmer climates in Sydney, we'll have climate zones 5. And then as you go up into Queen, it's got 5, I want to say 6 in there. And then as you go inland, it's 4. I'm just trying to remember off the climate zone map.
There's a couple of people who've just added the ABCB climate map as a link to it to everyone.
Fantastic.
So that you
yes.
can take, that'll take you to the exact detail.
Yes. Yeah. No worries at all. Thanks, Jason.
Wait, there's one other question, which performance solutions are site-based now. Would you help doing it? I'm assuming they're saying, Boris, would you help doing it? But that's
you don't need me for this standard. I'll go through it to just give you the background as to how it's been done. Yep. In effect, it's been developed through the formal process. I'll say it now. So the Australian Building Codes Board have a formal process for development of standards that are being viewed to be called up in the National Construction Code, which is the aim for this standard. So we've had discussions with the Australian Building Codes Board. They've been on our committee as we've developed up the standard, which is a requirement that they have. And as we've developed up the standard, they've been involved in its development. So the end goal for us is to get this standard called up in the Building Code or the National Construction Code as a reference document. So therefore it becomes a deemed to satisfy pathway, not a performance solution. But unfortunately, with the timing of things, NCC 25 is coming out, potentially in a month, and our standard isn't in there at the moment. So what you'd need to do to utilise our standard is get agreement with the certifier or building surveyor on the job that you can use the standard because it's gone through the formal process of a reference document. The only difference is at this point in time, it hasn't been called up, but the intention is it will get called up. So hopefully that gives you a little bit of confidence. But in terms of the standard itself, some of the systems that are in there have been modelled. So they're modelled solution that take into account thermal movement as well as condensation through the building elements. So it's all been done in accordance with the sort of modelled and verified approach. In our standard, we've got this risk factor table, which is basically a copy out of the NCC. So the NCC has this table if you're doing it under a design using what they term a verification method. So a verification method is a procedure that if you follow that procedure, you can comply with the NCC by showing that you demonstrate performance in accordance with the verification method. Both Volume 1 for commercial buildings and Volume 2 for housing have a verification method. And it's a risk-based approach. And as you see in the table, it depends on the wind area or the wind region you're in, the number of stories of your building, how the junctions between the walls and the roof, how exposed they are, how wide your eaves are to provide protection from potential entry points. Windows are one of the key areas that we want to provide adequate flashing. And so having eaves protection is a good means of providing that. So this is all in the standard. So you don't need to remember this, but this is all available in our design standard. But we also have details as to how you can design the battens where you're putting in a cavity. So we've got spacer battens, which are basically battens that run along your timber stud, just providing a cavity so you can get drainage in behind your cladding, or structural battens where they run horizontally and you fix your cladding to the structural batten that takes the wind force or the wind load. The spacer batten has got no structural performance, so you basically screw through your cladding through the spacer batten into your stud. So there's a key difference between those two types of battens. And here we've got a table that provides battens, batten sizes, which also cover off on castellated battens as well. So we've engineered designed those, and they are detailed in that table, depending on batten spacings as well as stud spacings. So it's all been engineered designed to comply with the wind forces on the external envelope of your building. Then the standard provides a whole range of details, and I'm just going to quickly skip through this. So we talk about how you can join various cladding elements. So in this case, we're covering off on the hardboard, showing details where you're doing joints between the studs or on the stud work in the far left-hand diagram there, or the figure. Also show flashing details around openings, which is a key area that you don't want to get water past that window. So we've got specific flashing details for those openings, and also showing you fixing and how you can fix various types of cladding profiles. Here we're showing just, we call them wall boards, but the weather boards or the profile boards. But we also cover off on hardboard products. So we show different types of cladding. So we've got overlapping with or without a spline, rebaited cladding boards, types of fasteners, also the wind speeds where they can be used, and the general stud spacings and the fixings based on where it's located on the stud. So studs that are in general areas that are now getting a bit into the wind requirements, but anything that's within 1,200 millimeters of an edge of a building has higher wind forces than they are when you're out within the center of the building. So there are different nailing configurations that you can use, or the requirements for within 1,200, you can apply it across the whole building or the whole wall, and you'll automatically comply. So you get higher wind forces near the edges of building. But then we'll also show typical fixing requirements. So whether or not you're fixing to a stud or fixing off stud in that central diagram. And then we show basic layouts and the installation of the vapor permeable membranes as well.
Boris, one other question from Gina. We now have wind ratings to N6 in Queensland. Where does that fit in?
In N6, well, our timber framing standards don't go to N6. I'd have to have a look at that. I'm sorry, it was Gina,
okay.
was it?
Yeah, no, we've got the details there, Gina. We'll come back to you.
Well, look,
after this
I suppose, just in relation to what we've got, we don't cover that up to N6. I'm really surprised about that, because even our residential timber framing standard goes to N4 and C3. But for the cladding, the wind forces, and it's basically trying to rip the cladding off. So we've limited ours to N3 and C1 for our cladding standard. So look, my first response would be, if you're in an extreme wind area, you'd have to talk to a structural engineer to ensure that the fixings are adequate for the cladding to hold them in place. But under our standard, we haven't taken that step. But I'll have to go back and have a double check on that.
We'll get your details, Gina, and try and come back and give you some more after this. Yeah, thanks, Boris.
But as I was saying, basically our cladding standard doesn't go to N6.
Yep.
So in the standard, what we have done is we've had a range of different systems that have been modelled. So modelled both for energy and moisture movement through the wall. So these are those that may have heard of been modelled using WFI software. And so these are the systems that have been deemed to use in these various climate zones. I'll apologise, we don't have all of the climate zones, and I need to go back and have a look at why we didn't do some additional ones. But I think one of the reasons was there was concern, and when this modelling was done, that there may have not been a big demand for these types of systems in some of the other climate zones, which I think has probably changed in recent years. Anyway, so we've got climate zones 2, 5, 6, and 7. Climate zones 1 and 8 aren't covered in the standard, so they do need to, if you in those areas, you do need to get some advice from someone that can do the modelling work to ensure that we don't get condensation occurring on the frame side. So where we want the condensation to occur is in this diagram on the outside of the vapor permeable membrane, so that it can drain through the cavities. So that's what the modeling's checking. It's checking where the condensation will occur and trying to force the condensation point on the outside of the membrane within that cavity in this system.
Boris, a question.
Yes.
Do you just have C1, C2, C3, do actually have pressure figures? Or do you actually have pressure figures? We've stopped at C1 for our cladding. All that happens is that you got to get the fixings. You have to have closer centres or closer fixings. We try to keep sort of with generic fixing requirements where we could. But look, I'm more than happy to take on board this feedback. This was our first development of the standard, and if we find there's real market need for further work, what the standard isn't set and forget. We'll constantly monitor and get feedback on the document and hopefully improve it over time. But for our first go, this is what we've done. And as I've said, we've gone through the formal process. We went out for public comment. We did the formal Australian Building Codes Board development process for documents that are seeking referencing in the National Construction Code. So at the moment, sorry, everyone, that's the best I can do for the moment. But by all means, if there are comments and people are wanting some additional information, more than happy to take that on board, and we'll look to add that in where we can. My one other question here, and we're getting to the ends, but I'll ask from Bruce Robb. How will you reconcile the differences in cavity widths required by NCC 2025 at 12 mil and the timber standard, which is looking for a minimum width of 18 mil based on the risk assessment?
Look, yeah, because the NCC is going, I suppose, with a smaller cavity. I think what we've done is that the risk assessment was done with that 18 mil. In my view, it's probably more the standard sizes that we get in the timber sizing. I mean, to do 12 mil is not a great size for us to use as a packer, but the 18 mil is more commonly available, is probably the words I'm trying to find, than a 12 mil. But look, all I can say is based on the modelling work that was done, and also enabling that, I suppose, ventilation to occur throughout that wall, the 18 mil was adopted. Again, that modelling work was done by a third party. And there's no reason why we couldn't look if that could be reduced to 12. But my first gut instinct is that we maintain the 18 based on the sizing that you can commonly get. And I suppose that's it from my perspective. Sorry, Jason, I don't know if you have anything to add to that, Jason.
No, I mean, the other part of the question is the structural battens. Can you expand on the note in the timber standard that requires the batten also to take into account the depth of the notches for the castellations?
Well, the sizes in ours allows for a castellation depth of 5 mil. So we've actually comped that into that size. So you can use those batten sizes with or without castellation. So that's the way that was done. I remember I had a look at the calculations, and the 12 mil notch depth is in that calculation.
Yeah. And I think getting back to that point as well, or previous, is the NCC is what we have to adhere to. The standard that FWPA's put out is a guidance. from what they've done. It's the NCC that everyone has to adhere to, correct, Boris?
Look, at the moment, that's the way, and it will be up until this standard gets referenced. But sorry, I shouldn't say it like that, because this will be another deemed to satisfy pathway. It won't be the only way. So if the NCC keeps the 12 mil and we've got an 18, if you want to use our standard, you use the 18 in accordance with our standard. But it's just when it gets called up in the NCC, it will just be an alternative deemed to satisfy pathway.
Yep. Mate, there's another question here. We might as well try and knock these off before the end. But recently, a CPD on avoiding condensation issues was recommending vapor permeable barrier on interior side as well as the exterior for climates like Melbourne, where we have hot and cold climate extremes. Also, intention was to have gaps to allow for condensation to wick away. Your diagram might need adjusting for alternative climate zones. From Deborah Johnson.
Well, yeah, I was just going to say, so these particular figures have been modelled through the climate zones as they're indicated at the base of the figure. So they have this system has been modelled through each of those climate zones. I do recall the webinar that you're referring to. It depends on the permeability of the element. I know because I'm actually doing a bit of an extension or renovation where one of the options was to minimise the moisture getting into the structure because it wasn't able to actually travel through to the outside easily. So that the comment was put another membrane on the inside to stop the moisture getting into your wall frame to start with. Putting that aside, these systems have been modelled using WUFI to show that the condensation will occur on the outside of the membrane for each of those climate zones. So hopefully I've responded to that. The other thing I was going to say quickly was almost that comment, Jason, that was made.
Yes.
Here's a system showing a CLT wall, whereas the membrane is on the CLT, not on the outside of the insulation, where currently the NCC says you put the membrane on the outside of the insulation. But when you run through this system, through the model, the WUFI model, if you put the membrane on the outside of the insulation, you get moisture onto your CLT.
Yes.
So this is where there's a conflict between NCC provisions and what we've modelled for this particular system. So I think that sort of shows that there can be differences for some reasons.
Mate, one other question before you just summarise. Excuse me. Yes. Has FWPA had a certified test process a performance solution through NCC using this standard?
Look, when you say process, as we said earlier, it's a site by site or a building by building scenario. So it's not really FWPA to put that forward as a performance solution. It's the person wanting to use timber cladding engaging with the building certifier for using of this standard. In my mind, it should be a no-brainer. We've taken this standard through the formal process of the Australian Building Codes Board for the development of referenced documents for the National Construction Code. So we've adhered with their protocol, and basically at the end of that process, we've now achieved or developed this standard. So in my mind, we've got a document waiting there for calling up in the NCC. So there's no further work that we need to do to our document if we don't wish to. If we do any further work, we'd have to go through that process again, going out for public comment, reviewing, which is part of the process. But anyway, so at the moment, all I'd say is that talk to if you've got a building or a house, it could be a single-storey school building that you want to put some timber cladding on. Talk to the certifier and just say, I want you to use this standard. Who else do we need to engage with in terms of developing up the performance solution? Because it's meant to be done in cooperation with all stakeholders in relation to that building. So, look, I know we're at the end. Look, I've left that summary up just to sort of give it an indication of the work that we've done and saying that we're showing some additional solutions like the CLT one. But basically where we're now going through is that last dot point's the key one, that we've gone through the NCC development of a referenced document process, And then the aim is to get this called up in NCC 2028 or NCC 29, whatever the year becomes. I think it's NCC 2029 is when it's meant to, the next revision of the NCC. So I'll leave it there, Jason.
Yeah, no, thank you, mate. I'm obviously a topical subject and lots of questions. So thank you for making the time to discuss what we went through. And as we mentioned, everyone will get an informal CPD certificate or sent to you after this particular event. You got Boris's details there. There's a lot of information gone into providing this standard as a guiding standard for the NCC moving forward, as Boris alluded to. And if there's any more questions, then please don't hesitate to reach out to Weathertex and or FWPA. So thank you for your time, Boris, and look forward to seeing everyone else in the next session of Weathertex Wednesday. Thanks.